Okay, so we decided to measure the flow of liquid out of the burette, and as you can see here we have other ways of measuring time in the past, and we found out that our way is going to be the best way today, and it's going to ensure that we win. And you can have pictures of us all doing our stuff on the wall there.
We decided to measure the rate of change of voltage over capacitor as it's charging, and we wanted to make it a bit more interesting, so we decided to introduce voltaic cells into the whole thing, which is basically a battery. So unfortunately we just developed a bit too much resistance with our voltaic cells, so it took a bit of changing to make it work. But we measure the change of voltage over time and using Denton's mathematical equation, which he managed to develop on the board, we can eventually get the time taken over the change in charge.
Go. So we are going to be measuring time using this toy car. It's going to be going around in a circle, and we've calculated the time period for this car, and then using that equation we calculate the angular frequency, and when the song plays we will set the car off, count how many circles it performs, and count how much time it took to perform those circles using again that equation, and then rearrange the bit, and then if it goes any extra angles, we will convert that angle to radians, and again rearrange that equation. We'll find the time for that.
Can you just give us a quick demo of the car?
Yes, I can.
Doing the iodine clock reaction where we mix two colourless solutions together, and it stays colourless until a bit of time, and then the reaction will turn blue straight away, depending on the concentration of the solutions, and then from that we can take the time from that. Not the most reliable experiment in the world, but we're still going to win.
Okay, so basically we came up with this idea based on the idea that often explosions have a set amount of time, so grenades, bombs, fireworks, and from that we kind of developed several ideas that we could use. We developed the idea of using a splint, but basically we eventually settled on using magnesium ribbon as our primary fuse, as it were, purely because it burns the most consistently, and we were able to calculate it most easily. But as a backup, to make doubly sure, we've also soaked string in paraffin, a kind of more traditional fuse that you might find on a more old-fashioned bomb.
Yeah, I'll start from the top. Here's a horrid picture of me looking quite miserable next to our experiment. So that's when we first tried it out. How it works. An air current is produced from the electrical fan, which in turn turns the blades of the windmill, hopefully at a constant rate. Then a beam from the laser goes through to reach the photodetector on the other side, which hopefully will be switched on as well. And when the blades turn, the blades block the laser light, and hopefully the blinks that are produced from the light being blocked will be constant as well. So we'll be able to calculate the time from the blink.
And then press the red button again to start.
That's right, we got number 2.
We think it's resistance drop. For some reason it doesn't the voltaic cell. We've got a battery running at the moment that charges up the capacitor, and why that has developed some change in the voltage over time. Sorry?
I'll give you a little bit of time to to do your calculations. I'll look at your watch if you're cheating. If you close the door.
7.5 centimeters, 7.5 centimeters. That's not going to be
You take it so well. Forget it, Jack. You're just trying to pretend that's your experiment.
Wow.
Yeah.
You want to win. Enjoy the beer.
An evening. I'm just going to take a picture of Cherry's very simple car experiment with a stick and a string. Hi, Cherry. Hi, Cherry.
Go measure that one.
Okay, so definitely. Yeah.
Fine.
What are we gonna go for?
3, 2, 1.
Yay! Yay! Woo!
The Great Country Hit by John Denver, Take Me Home Country Roads, is a total of 3 minutes and 10 seconds, which means the Iodine Clock wins.
Yay!